Okay, 12, we have a right perpendicular cone, volumes given by 1/3 pi r cubed, h. For this particular cone, the height is equal to 8/5 of the radius. And my pen is tangled. There we go. There we go. Okay. So again, the volume is given by this formula, which you do see the cursor. There we go. If I give my volume is equal to 1/3 pi r squared h, and then I'm told that the height is 8/5 of the radius. Okay. That means I can reduce that volume formula down to this. Okay. Quick simplification job tells you that the volume is then equal to 8/15 r cubed. Now that is a nice compact formula.
Pi.
Yeah, pi. Okay, we're supposed to find dv dt. Okay, dv dt. Oh, notice that we substitute before we take the derivative. Very key point here. Substitute before differentiating. Substitute / simplify before derivatives. Before derivatives. Okay, so dv dt is equal to pi times 8/15 times 3r squared times dr dt. Okay, we can now substitute the things that we know. We know that r is 5 and dr dt is -3. dv dt is then equal to, well, we can simplify that also. That's 8 pi over 5. We are told that the radius is 5 squared, and we're told that dr dt is -3. Oh gosh, we can cancel out another 5. 5 times 8 is 40. 40 times 3 is 120. So this means that dv dt is -120 pi. Okay? Oh, you know what? I really should mention this, because I made this thing about substituting. I don't want you to have any confusion about this. So when I say substitute, okay, do not substitute values. Don't substitute that in. Substitute secondary equations. Okay. Unless, of course, the variable is constant. Boy, that looks really ugly, doesn't it? Do you think it'll simplify my handwriting for me? Let's try it. Tendon. What did I write?
Do not substitute values.
Oh, you know what? This was the star. Star. Don't Substitute valves.
Valves.
Values like
2 equals 5.
r equals 5 unless the variable. Oh, the second sentence is good though.
Yeah.
Wait, how did you do that?
He highlighted it.
I'll show you. I'll do it again, right? Watch. Hello.
Hi.
I'm going to select it. You're going to right click and then convert handwriting to text. Bam!
Nice. That's so cool. I don't think I can do that.
I bet you could.
If you have this program,
I do have this program.
then you can.
Everybody has this program. It comes preloaded.
Unless you have a Mac.
Well, yeah, if you have a Mac, you have other problems.
You have
Wait, I
what?
have it on my
You have other
phone.
problems.
No way, oh my.
13. 13. Alexis, who is 5.7 feet tall, note that's not 5 feet 7 inches, walks at a rate of 5 feet per second toward a street light that is 20 feet above the ground. At what rate is the length of her shadow changing when she is 10 feet from the base of the light? Draw a picture. Yeah, I like that. Let's draw a picture. Let's draw the picture. And I think the picture is a right triangle. It is. Oh. Let's see. So we can. No. No. How about control? No. Control Z. Shift. No. Control Shift. No. Whatever. Let's draw them. This is going to be the ground. Okay. This is going to be the height. I'm going to pretend I don't know what I was doing. You can pretend that too. There we go. We got a right triangle. Alexis is going to be here. She gets to be a line. Okay. This right here is shadow. Shadow. And this right here is a light. Okay. Now is a good time to substitute constants. Substitute constants. Okay, so we know Alexis is 5.7 feet tall. She's not changing height. She's not growing that quickly. We know that the street light is 20 feet above the ground. And that's it, right?
No, we know the length is
She's 10 feet from the base.
Is that constant or is that changing?
No, that's
We know her velocity.
We know her velocity. Yeah, we do know her velocity. But I think I just want to deal with lengths right now. Okay, so geometers. Geometers. What is my ratio?
X over 5.7
X over 5.7.
is equal to X plus Y over 20.
X plus Y over 20. Yeah, that's right. Notice that X and Y are changing. Even though we have values for them now, they are changing. Okay. All right, so this means 20x equals 5.7x plus 5.7y. This also means that we have, what is that, 14.3? 14.3x minus 5.7y is equal to 0. Now we can take derivatives. 14.3 x prime, sorry, dx dt minus 5.7 dy dt equals 0. Okay, so the speed at which she is moving toward the cone, is that dx dt or dy dt?
Y dt.
It's dy dt. Yeah, dy dt is 5. Is that negative 5 or positive 5? It is negative 5. So we're going to make that substitution now. So we got 14.3 dx dt minus 5.7 times negative 5 equals to 0.
Why is it negative one?
Negative 5 because y is getting smaller.
Oh.
If something's getting smaller, they get a negative derivative. 14.3 dx dt minus, let's see, 25, 35, 28.5 plus 28.5 equals 0. Okay, good. dx dt then should be negative 28.5 over 14.3.
1.99. Negative.
Yeah.
Negative 1.993.
Mhm.
And we're supposed to go to the nearest 0.5 feet per second. So negative 2. So this means that the shadow is decreasing. So not the shadow length. Is decreasing. At 2 feet per second. Do you think I could turn that into text? What's wrong with that?
It's gonna, yeah.
It's gonna mess up the shadow.
Shadow's gonna mess up?
Yeah.
We'll
I
see.
believe.
We'll see. We'll see. Boom!
Wow.
It
It
didn't
didn't do per second.
Wonder why.
Hey, why did it bold it?
I don't know.
But it was all in okay.
Huh. Alright, whatever. Let's move on. Where are we? That wasn't that bad, right? 14? 14, a balloon the shape of a sphere is being blown up. The volume is increasing at 4 inches cubed per second. At what rate is a radius increasing when the radius is 1 inch per second? 14. 14. Okay, so we want to know at what rate is the radius increasing, right? And we're given a volume. So I'm thinking the volume formula is going to play a part here, right? Volume of a sphere is pi r cubed. Good. Do we have any constants? No, we don't. Okay, so now we can take a derivative. dv dt is equal to 4 pi r squared dr dt. Let's put some things in here. The volume is increasing at 4 inches cubed per second. 4 pi. And the radius is currently 1. And we want to know what rate the radius is increasing. Oh wow, this problem is done for you. It's 1 over pi, yeah? dr dt is equal to 1 over pi feet per second.
Is it inches?
Is it inches?
It's inches.
My bad. Inches per second when the radius equals 1 inch. No problem.
Glad you like
Okay, 15. 15. Find the area of the region bounded by blah and blah. Okay. This goes back to that question we had in class. Do I need to graph this? Yeah, I think you're going to have to graph this one. I have no idea the way that this cubic function looks, other than the fact that it's a cubic function and I can make the general cubic shape. So I'm going to want to graph that. We have y equals x cubed minus 6x squared plus 8x. I can factor out an x, right? X squared minus 6x plus 8. I think that's factorable. X minus 2x minus 4. That means I have 3 roots. X equals 0, 2, and 4. Awesome. Now I know a lot about the way that this looks. Do you remember is it called the lead coefficient theorem? Wait, no, not that lead coefficient theorem. The one?
With the increasing the endpoint.
Yeah, increasing with the endpoints. Okay, so is this going to start by increasing or start by decreasing?
Increasing.
Definitely starting by increasing.
Oh, right, because it's like positive and odd or something.
Mm-hmm. Positive and odd, that's perfect. It's definitely going to start by increasing. It's going to go through there. It's going to do one of those. And then it's going to also end by increasing. Okay. This is not drawn to scale. I have no exact idea about where all of those maxima and minima are. Okay, so I want to know the area of the region bound by that and the y-axis. Okay, here's the y-axis. I'm going to do it in red. Here's your y-axis. Okay, I'm not going to do it that thin. I'm going to make a nice one. Good, 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 good.
It's not the x-axis.
That is the x-axis, yeah. And the y-axis. Oh no, y equals 0. It's not the y. It's not the y-axis. It's y equals 0. Here's y equals 0.
Yeah.
It doesn't say anything
If it
on
was
the
y
axis
equals
or
1,
anything. He just knows that.
What do you,
It's good.
Oh,
Good.
got it.
Okay, where's my area?
The two things.
The 2 loops. Got to find the area of loop 1 and the area of loop 2. Good.
What do you call loops?
No. I was going to call them humps and then make a horrible Fergie reference. So I'm actually kind of glad you said loops. It's much better. Okay, region 1, let's call this R1 and R2. Let's find the area of R1. That's going to be equal to an integral from x min to x max. Which curve is on top, blue or red? Blue, good. X cubed minus 6x squared plus 8x minus, the curve on bottom is 0, right? Dx. Someone really smart's going to say, do I need to put that 0 there?
I need to put that 0 there.
Then I'm going to say, no, you don't have to, but since I'm teaching, I'm going to have to show you that 0 is actually there. Antiderivative 1/4 x to the 4th minus 3x 2x cubed plus 4x squared from 0 to 2. is equal to 2, 4, 16, 4, 8, 16, 4, 16. Oh, the area is 4.
Is 4.
Area of region 2. Area of region 2. Now the red curve is on top, right? Now that 0 makes a difference.
Just makes it
It makes it
negative.
2, 4.
X cubed. Yeah. Cubed minus 6x squared plus 8x dx. Let's integrate that. Integral of negative x cubed, negative 1/4 x to the 4th. Integral of 6 plus 2x cubed minus 4x squared. We're going from 2 to 4 this time. Okay, let's plug in 4. 4 times 4 is 16. 16 times 16 is 256. 256 divided by 4 is 64. 4 times 4 is 16. 16 times 4 is 64. 64 times 2 is 128. Minus 4 times 4 is 16. 16 times 4 is 64. Oh my gosh, that's 0.
Yeah.
Yay.
Oh.
Minus the 2
No,
point.
that's
Minus.
Minus negative 4, so just
Wait, minus what?
Minus
2 times 2 is 4. 4 times 4 is 16. 16 divided by 4 is negative 4. 2 times 2 is 4. Times 2 is 8. Times 2 again is 16.
cancels out. Minus 16.
Oh, it's 4, right?
Yeah.
4 plus 4 is 8.
What?
He's a child.
Isn't that area negative? So it has to be negative.
No.
No.
On the bottom of the
Not the way that we did it.
Yes.
Okay, that's 15. I think we're good.
Yay.
Yay.
that one.
Oh, wow.